Welcome to Physics Concepts, Lecture 5. Today, we will explore Newton's third law of motion, which is fundamental to understanding interactions in physics. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. This principle is illustrated in the interaction between a hammer and a stake, where each exerts the same amount of force on the other. When you lean against a wall, you exert a force on the wall, and the wall simultaneously exerts an equal and opposite force on you. This is why you don't topple over. Similarly, a punch on a massive bag exerts a significant force, but the same punch on tissue paper exerts only a tiny force. Newton's third law can be seen in various scenarios. A tire pushes on the road, and the road pushes back on the tire. A rocket pushes on gas, and the gas pushes back on the rocket. A man pulls on a spring, and the spring pulls back on the man. The earth pulls on a ball, and the ball pulls back on the earth. The earth is pulled up by a boulder with just as much force as the boulder is pulled downward by the earth. This interaction demonstrates the equal and opposite forces described by Newton's third law. The force exerted against the recoiling rifle is just as great as the force that drives the bullet. However, the bullet accelerates more than the rifle due to their differing masses. This principle is crucial in understanding the behavior of firearms and rockets. Let's summarize some key terms. A vector is an arrow drawn to scale to represent a vector quantity, which has both magnitude and direction. Scalar quantities have magnitude but no direction. The resultant is the net result of combining two or more vectors. When two vectors at right angles to each other combine, their resultant is the diagonal of the rectangle they form. For example, the resultant of 30N and 40N forces is 50N. A 60 km per hour crosswind blows an 80 km per hour aircraft off course at 100 km per hour. The resultant velocity is determined by combining the two vectors, illustrating how different forces interact to produce a net effect. The horizontal and vertical components of a stone's velocity can be constructed to understand its overall motion. This helps in analyzing projectile motion and predicting the path of moving objects. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video for the benefit of other viewers. What did you learn from the video? What topic would you like to explore further? Fair use disclaimer. This presentation contains copyrighted material used under the Fair Use Doctrine for educational, commentary, and research purposes. All rights belong to their respective copyright holders. Links are provided in the video description to relevant resources.